Good morning, children. Today we will study classification of elements and periodicity in properties. If you will open this chapter at home, children, after the class, you will find that they have given you syllabus as they used to give you in class 10 also. There used to be a block in the beginning of the chapter. Here it is given totally separately in the beginning. You will open, you will find the topics to be covered up in this chapter. So our chapter today is classification of elements and periodicity in properties. So the first topic which was given there is modern periodic law. Children, this you know from class 10 also. What is modern periodic law? Modern periodic law was given by Moseley. I hope you all know. It says that the physical and the chemical properties of the elements are the periodic function of their atomic numbers. I repeat, the physical and the chemical properties of the elements are the periodic function of their atomic numbers. Right? Then children, we have to study this whole modern periodic table. So children, I have tried to draw this modern table for you all, although my drawing is not that good, but hope you'll try to understand. Now children, this is our modern table. It has got 18 vertical columns, 1, 2, 3, 4 and till 18. And it has got 7 horizontal rows. These vertical columns, 18 vertical columns are called groups. These are 18 in number, they are called groups. And the horizontal rows are called periods. You know very well from class 9th also. Now children, you have been taught the chapter atomic structure where you have been taught writing of electronic configuration. So if we give you atomic number, I'm pretty sure you are able to write electronic configuration correctly. Now, so when you write electronic configuration as 1s2, 2s2, 2p6 according to Gauss principle, children, you write that. You fill electrons. So while filling, if the last electron was entering in S subshell, it was found that they were belonging to group 1 and 2. So we called it S block. It was on the left side. If while filling electrons, writing configuration, the last electron was entering P subshell, so they were found to be there in groups 13, 14, 15, 16, 17 and 18 and they all were placed here. So this was named accordingly as P block. Then while filling electrons, if the last electron was entering D subshell, they were placed here in the middle of this table and hence we call this D block. Then what happened children? Here, this is lanthanum 57, belongs to 3B or say group 3 according to the modern way of numbering. Old way, old pattern 3B, modern is 3. Here we had lanthanum 57. After this it was found that there were 14 elements, each having electron in F subshell, 4F1, 4F2, 4F3 and they all were finding place here only. Since they could not be placed here, so they all have been placed together separately because this could have been congested. So from here they have been brought down 58, 59 until 71, 14 elements. Means after lanthanum, we had 58, 59 having configuration 4F1, 4F2, 4F3 likewise. Similarly, this was in period 6, 9, 7th also. After actinium, the elements were having the last electron entering 5F, 5F1, 5F2 and likewise it was going. So, and they were finding place here only due to configuration. So what happened? Again, we cannot put so many together. So they were brought down from 90 till 103. So we had 14 elements here, additional in this group, in this place, at this point. Similarly, we had 14 additional elements here also. So since they could not be placed here, so 14 from here have been brought here, this row, and 14 from here have been brought here, this row down there. So 14 elements of this place, this position, and 14 elements of this position have been brought down separately in two rows of 14 elements each. In period 6, the electron was entering in 4f, so we call it 4f. This is your 4f. Because they were after lanthanum, so we call them lanthanides. Then here, the 14 elements were from atomic number 90 to 103, since they were after actinium, and the last electron was entering 5f. So they were called 5f elements, and since they were after actinium, they were called actinides. So what all you see here, actually, they were supposed to be placed here. But since it could have become congested, study would have been difficult, and here the last electron was entering D, but they were found to have F, so they have been totally separated from there. And as you all know, children, chemistry is full of exceptions. So one side, the place was here, at the same time this had last electron D and they had last electron entering F, with the result they had to be separated, because here 4F means we had 6s2, right? So here it was lanthanum only, 6th period, and elements were here. This is 7th period, 5F elements were here. So this way, children, and they were called F block elements. So a modern table which had 18 vertical columns called groups, 7 horizontal rows called periods. While writing electronic configuration, if the last electron was entering S subshell, they were placed in groups 1 and 2, and this block is called S block. If the last electron was entering P subshell, electron was they were placed in 13 to 18 groups. They were called P block. If the last electron was entering D, they were called D block, and accordingly I told you F block elements. This is how we have a simple picture of our modern periodic table. Then, children, as I told you, vertical columns, we call them groups. What does group tell us? Or through group number, what do we come to know? What information do we get? So children, I tell you, although you know it also, in a group, top to bottom, what all elements we have? They have the very same electronic configuration for the valence shell. All elements of any group, whichever you go, they have the same electronic configuration or similar electronic configuration for the outermost shell. Better to say similar electronic configuration. General will be same. They have same general common electronic configuration of the valence shell or similar electronic configuration. All elements of the same group have the similar electronic configuration or the same electronic configuration of the valence shell. Then periods. This period tells us the number of shells present in any atom. All the elements belonging to any particular period, all the elements, they will have the same number of shells in their atom, or same will be the number of the outermost shell. Or in short, through this we get an idea about the principal quantum number n. So this is how, children, sorry. So this is how it is there. This tells us, periods tell us the number of shells, total number of shells, or we get an idea about principal quantum number. These tell us the electronic configuration. All the elements of any particular group have the same electronic configuration. Then in short, children, this classification, we know that first period is the shortest period having 2 elements. Then second and third, they have got 8 elements. Fourth and fifth are long periods having 18 elements. Sixth and seventh period. Sixth, they say, is the longest period having 32 confirmed elements. And seventh, some books report incomplete. Some books call it again like this, longest, because they both have 32 elements. They say group 6 has 32 reported elements. Group 7 can have 32 elements, but some are still not reported. But mind you, some new books and science magazines and all, they are still reporting all 32 elements. So shortest, the first, second, third short 8, 8, 4, 5, 18, 18, 6, 7 have got 32 elements. Here completely reported, here they say incomplete. Your book says incomplete, but some are reporting 32 complete. At the bottom we have two rows of 14 elements each. If the electron was entering 4f, we call them lanthanides. If electron was entering 5f, we call them actinides. Then children, here we know group 1 elements, from class 10 were called alkali metals, group 2 were called alkaline earth metals. Then group 11, this 11, it has copper, silver, gold likewise, so we call them coinage metals. Then group 15 we call them nicogens. It has nitrogen, phosphorus, sulfur, nitrogen, phosphorus, etc. We call them nicogens. Group 16 we call them chalcogens, oxygen, sulfur, etc. And then 17 is halogens, and 18 we call them noble gases, noble elements, rare gases, inert gases. Some books even call it acrogens. So this is a common picture of our modern periodic table proposed by Moseley and his team. And the principle, the base was modern periodic law, which says the physical and the chemical properties of the elements are the periodic function of their atomic numbers. Vertical columns groups, horizontal rows periods. This side we had S block, that side we had P block, in between D, at the bottom we had F block. So I stop here. In my next video, children, we will study these types of elements and study of these blocks in detail. So I hope this was a simple idea and you have understood. It was simple, just a revision of class 9th and 10th. So we stop here for this video. Hope it is clear. Yes, children, what all points I tell you, wherever I feel you cannot manage, I'll be giving you additional points as kind of notes. But what all I've told here, you can simply revise at home, and what all I'm saying, or like you take it as a dictation and you note down. If the repetition is there, you don't note down that point, but any point which is there, I've spoken, I've told you, please keep on noting down once you revise and see this video at home while you revise your chapter. So just note down the points.